Precalculus, Lesson 13, Chapter 2, Section 5, the Fundamental Theorem of Algebra. The fundamental theorem of algebra basically says that whatever the highest power is of the polynomial, maybe it's a 4, whatever the highest power of the whole thing is up to how many answers it can have. It has 4 answers. They might not all be real answers, but it's got 4 solutions, real or imaginary. So we're going to work today on finding the imaginary answers. And to find the imaginary answers, you have to understand that when you have one imaginary number, you have the other one too. You have the conjugate of it. So if you have a plus bi, you also have a minus bi. Or in other words, if you have 3 plus 4i, the equation also has the answer 3 minus 4i, the conjugate of it. The conjugate of plus is minus, minus is plus. So you've got them both. All right, so we're going to find the zeros down here on the next one of the function and write the polynomial as a product of linear factors. Use a graphing utility to verify your results graphically if possible. Use the graphing utility to verify the imaginary zeros. Okay, so these are both perfect squares. 81 is 9 squared, and 625 is 25 squared. So you have a difference of squares here. So 9y squared minus 25 times 9y squared plus 25. And you've got, this is still a difference of squares again. So you can change that to 3y plus 5 times 3y minus 5. And then times 9y squared plus 25. This doesn't factor anymore under the real system. But you can keep going with it if you make it the letter I. And we learned about i's yesterday. Because if you solve this, 9y squared plus 25 equal to 0, move the 25 over, so you got negative 25, divide by 9, negative 25 over 9. So taking the square root of that, it'd be plus or minus the square root of 25 over 9, and it was negative. So the square root of negative, so you're going to have to take it out, and it's going to be an I. So it's 5/3 I. So if you want to, you could change that then. Well, we have to. They said in the right is a product of linear factors. So again, churn it. So that makes it 3y plus 5i, and then times 3y minus 5i. And that would be as a product of linear factors. And again, they also wanted to know what the zeros were on it. So the zeros are plus 5/3 I, minus 5/3 I, and then we have these two answers here of negative 5/3 and positive 5/3. So on this page we learned the fundamental theorem of algebra says whatever the highest degree of the polynomial is how many answers it has. They might not all be real answers, they could be imaginary answers, and we learned the conjugate pairs theorem, sort of. We'll call it a theorem for fun. I don't think it is. I don't know what they called it, a definition or something. Anyway, if you got 3 plus 4i, you've also got 3 minus 4i, and vice versa with the plus and the minus. On the next page, we got the same thing again. We need to find all the zeros. So what we learned how to do on that was the this one theorem that said that all the possible zeros were the factors of the last number, the constant number, over the first term. So the factors of 9 over 1. So the factors of 9 are 1, 3, and 9 over the factors of 1. So that gives you some possible answers. And I told you guys what you can do too overall is put it in the calculator, see where it crosses the x-axis at. That'll work for us. So turning it on here, y equals x to the 4th. And then plus 6x to the 3rd plus 10x squared. You might notice I got an older calculator here. I got a pile of them, so I know I was using a newer one yesterday. I don't know, I just grabbed one. So you can use an old calculator like this, it doesn't matter. Okay, so look right there. It's got the number negative 3. And so these possible answers again were plus or minus all of them. And so we have a negative 3. And look at it, how it goes down and touches it. So that means it's got a multiplicity of 2. So two of the zeros are -3 and -3. All right, so we wanted to write it as a product of linear factors. So what we're going to do is divide out that -3 using synthetic notation. So we got 1, 6, 10, 6, 9. Bring on the first one, multiply, add them up, multiply again, add, multiply, add, and then multiply one more time. We got 0. Again, I told you if you don't get 0, you did something bad. Go back and look at your work. So I got rid of one of them, but there's two of them. So I need to divide again. So I'm going to divide again by -3. So bring on the 1, multiply, add, multiply, add it up, and multiply, and again we get 0. So I divided out two x's. So instead of x to the 4th, since we've divided two of them out, we're left with x squared and then plus 1. So the linear factors here we have it are x plus 3, x plus 3, and now we got x squared plus 1. So just like I did on the last problem, if you want to, you can set it equal to 0 and solve it, and that gives you then plus or minus the square root of -1, which is the letter I. So that makes it x plus 3 times x plus 3, and then x minus I, and then x plus I. And so those are the other two zeros, I and -I. And then we're done with the whole thing. This is the product of linear factors, and they wanted to know what the zeros were. Okay, on the next one, honestly, it's the same question. They want us to find all the zeros of the function, write the polynomial as a product of linear factors, and use your factorization to determine the x-intercepts of the graph. Well, the x-intercepts are kind of the zeros. So, yeah. So, again, doing it the long way, you can do the factors of 16 for the possible zeros here. Possible zeros for x that it could equal are, again, the factors of 16 on top over the factors of the first term there, which is 1, the first coefficient. So it's only 1. So 16 divides by 1, 2, 4, 8, and 16. So it could be any one of those numbers, again, plus or minus all of them. And again, it's easiest just to look on the calculator, see which one it is. All right, so y equals, hit clear. We got x to the 4th minus 8x to the 3rd plus 17x squared minus 8x plus 16. Ah, look, it goes down and touches it again. So it's got a multiplicity of 2, and it's the number 4, a positive 4. So the zeros of it, x could be 4 or 4. So we're going to do the same thing again. Let's divide it out. So dividing it out here, we got everything there. There's nothing missing. So we got 1, -8, 17, -8, 16. Bring down the first one, multiply, add it up, multiply, and then multiply again, and one more time, and then I have to divide out another 4. So divide again, and let's see, multiply, add, multiply. All right, so we got x squared plus 1 again. So it's linear factors. It's x minus 4, x minus 4, and it's got x squared plus 1 again. And we just did that on the last problem. That factored into x plus I and x minus I. So product of linear factors, well there, that's the product of linear factors. The zeros were 4, 4i, and -I. Those were all the zeros. And that's what they said on A to do, find all the zeros. Write the polynomials or product of linear factors, did that. Oh, so the x-intercept is just the number 4. So I guess that's how it's different. They want the actual number where it crosses the x-axis at, and it crossed it as we saw at the number 4. So it has one answer, the letter C, x equals 4. All right, on the next page, it says, find a polynomial with the given zeros. So they gave us the zeros here were -3, -3, and I, And hopefully you remember back to the beginning of the lesson, if you got one letter I, you've got the other I. And this is a plus I, so the other one would be a minus I. So they want us to write the polynomial with real coefficients. So the polynomial, again, would be x minus negative 3, which is x plus 3. And then we got x minus I and x plus I. So this is a product of linear factors. And then we need to multiply it out. Always multiply your i's together. Life is just so much easier when you multiply the i's together. You'll see. Over here, if you FOILed that out, you get x squared plus 6x plus 9. FOILing this one out, you get x squared and then negative xi, positive xi, and then last of all, you get a negative I squared. And remember, I squared is negative 1, so that turns into x squared plus 1. And then you got to keep going. You have to FOIL that out now. So FOILing that out, I'm going to go this way and multiply all of them by x squared. So it's x to the 4th plus 6x to the 3rd plus 9x squared, and then multiply all of them by 1. So that's x squared plus 6x plus 9. So when you add it all up, you get x to the 4th plus 6x to the 3rd plus 10x squared plus 6x plus 9. That's the answer to the whole thing. Okay, same thing on the next one here. We want to multiply it all together. So we got x minus 0, x minus 4, and then we got x minus 1 plus radical 2i, and then we've got x minus, if we got one with a plus, then we got the other one with the minus. So we also have 1 minus the square root of 2i. So x minus 1 minus the square root of 2i. All right, and that's a lot of fun to multiply together. So again, you're going to multiply these together, and let's multiply that together. So this is just x. X minus 0 is x. So x times x is x squared, and x times minus 4 is minus 4x. All right, so over here doing this whole thing. All right, so I'm going to, well, I like just FOILing them out as a chunk. So x times x is x squared, and then x times that gives you minus x times 1 minus radical 2i, and doing the inside one, it's minus x times 1 plus the square root of 2i, and then minus times a minus is plus, and then you've got 1 plus the square root of 2i times 1 minus the square root of 2i. All right, so just doing some work over here on the side, we've got x squared minus 4x, and then here we got x squared. Let me use a different color. Right here we have minus x plus the square root of 2i, and over here we have minus x minus the square root of 2xi. That had an x on it also. So these canceled out, and minus x and minus x make minus 2x. Okay, and then the last one here, 1 plus the square root of 2i times 1 plus the square root of 2i, you've got 1 minus the square root of 2i, and on the inside plus the square root of 2i, and then plus times the minus is minus 2i squared. Radical 2 times radical 2 is 2. Those are gone. I squared is negative 1, so that really makes 1 plus 2, which is 3. And then you'd FOIL those together, and when you FOIL those together, you get x to the 4th minus 6x to the 3rd plus 11x squared minus 12x. Okay, on to the last page. On the last page here, we're doing the same thing again, except this time they gave us a point on the graph. Again, an equation has an infinite number of points. Both of those last two that we did, you could put a letter on the front of the whole thing, the letter A, and multiply across by all of them. Same thing here. You could put an A on the front of this, some number, and multiply by across by the whole thing, and you have the same equation. You're going to have all the same zeros. No matter where, it's going to intercept the x-axis in the same place, no matter what you multiply by. So it helps to have an actual point on the equation to find the exact equation of it. So overall, what we're doing here, we have a polynomial f of x is equal to some value of a, and then times, let's see, a x to the n plus, x to the n. Let me see here. The front page had a polynomial on it. No, it didn't. But anyway, there's some a there, and so we're trying to find what it is. So let's start here. We have 1, a negative 4, and radical 3i, so we also have minus radical 3i. So setting the function up here, we got x minus 1 times x plus 4 times x minus radical 3i times x plus radical 3i. And then we have this point here, x is 0 and y is negative 6. So we want to find some a value that the whole thing's multiplied by, and that's why they gave us a specific point for the equation. This is going to give us the exact equation. Unlike that last two, it didn't give us an exact equation, but it gave us an equation that went through those zeros. So we also want to plug this point in now, 0, negative 6. So negative 6 is f of x. We want to find a, and x is 0, so 0 minus 1, 0 plus 4, 0 minus negative 3i, and 0 plus radical 3i. Hey, David, just throw those rolls in the convection oven with the french fry thingies and just set it for 5 more minutes and then it'll be done. Okay, so finishing it up here, we're having chicken tonight, rolls, peas and carrots. I know you're jealous. All right, here we got negative 1, 4, and over here we've got negative 3i squared when it's multiplied out. Radical 3 times radical 3 is 3. And I times I is I squared. So let's see, we got negative 6, negative 4 times this is going to be a positive 3 because I squared is negative 1. So it's really positive 3. So negative 4 times 3 is negative 12a. So you get negative 6 divided by negative 12, or a half. So a is 1/2. So writing the whole thing out then, f of x is equal to a, which is 1/2, times all of this, x minus 1 times x plus 4 times x minus radical 3i times x plus radical 3i. Then you got to FOIL that out like we did on the last 3 problems. Multiply these together, multiply the conjugates together, and then multiply everything by 1/2, and you'll get that answer of 1/2 x to the 4th plus 3 over 2 x to the 3rd minus 1/2 x squared plus 9 over 2 x plus 6. All right, I'm going to go have dinner. I'll see you in a minute for the next lesson.